Yeah, appreciate
No,
it.
it's fine. It's not that late.
That's not that late for all of you. Okay, thank you. Good morning, Jeff.
Good morning, Sue.
I think we're going to give it 5 minutes and see how many people we get in addition. If we get a quorum within that time, I'll start earlier. Good morning, Juan. Oh, he's on Zulip. I'm not going to get a high back. Okay.
Hi, Sue. Hi, Jeff.
Thank you.
Thank you for the meeting.
You're welcome. It's good to have you here. And
Thank you.
pronounce your name one more time, Dr.
Yuja. My name
Yusha.
is Yuja. Yeah.
Yusha. No, I'm not. Uh, thank you for, Yusha, thank you for responding to me during your holiday time. I appreciate that.
It's fun. And thank you for your patient reply.
Okay. Thank you. I'm going to go ahead and start and give the discussion on uh, the note. Well, this is a IDR interim. It is a focused interim to discuss something, but it is still an ITF interim. This is the the ITF policies on disclosing IPR. Remember, as by participating in the ITF, you agree to follow ITF processes and policies. If you're aware of any ITF contribution that's covered by patents or patents application that are owned by you or controlled by your sponsor, you must disclose that fact or not participate in the discussion. Any participant or attendee to any ITF activity means you acknowledge that you agree to the written audio and video photographic records, and any personal information will be carefully handled by the ITF in accordance to IETF privacy statements. Um, and you agree to be respectful to other participants. That's usually works fairly well in our interims. So with that, I'm going to launch into our agenda slides and see if we can get some feedback from design team 1. These are structured as design teams, only that I expect some sort of interaction with people who are talking or working with us. I see we have a smaller group today, and that's just great. That will allow us plenty of time for feedback. We are looking for feedback from the IDR FlowSpec V2 specification. As the author of that specification, as one, excuse me, as one of the co-authors of that specification, along with Donald, um, I'm leading the discussion. Jeff is playing an ITF chair for this for this working group. He does have some of the drafts. We've tried to guide the IDR FlowSpec V2 work as chairs, and we're taking on these interims to try to catch up with things. So we're going to go through the agenda bashing process right now. We're going to go through the agenda, make any comments in case you're new. The first thing we're going to do is we're going to spend the first half an hour talking about FlowSpec for basic IP. This was a sequence that I'm trying to get some feedback because we're trying to set the basic uh, uh, form of the LRI and actions, and then we're going to go on to talk about that. Um, Boy, I'm tripping over my words this morning. Excuse me, maybe more coffee would be appropriate. Then we're going to talk about additional filters. I'm going to give you the general idea of how we intend to extend the filters. Then we'll talk about filters for the application layer, filters based on grouping things, or actions based on grouping things would be the appropriate thing. And we'll go through that. That is really considered the work of design team 2. And I will walk through things, and we will have presentations on interface set and then on emerging filters from CAT, SAFNet, and APN. These are filters that we'll go through. We'll talk about some questions, and then we'll go for the action items at the end. So I believe last week we had most people here. Donald is a co-author. G is our working group secretary, but he also has one of these drafts. Would anyone else like to share their background on what they're doing? I think that Nat told us he was operational. Randy's always here to keep me operationally straight and intellectually honest. Shuping is an author of the APN draft, and Young and Yuzha are newcomers to IDR, and they're working with some IP filters for packet inspection. So I think we have a good group this morning. Any questions? Is there another Randy? No. Thanks, Randy. Say something nice and I get. I like that. Okay. If you want to join the team, I think that please do. I think most people have volunteered, but please join, convince other people. The teams, just in case uh, you might not remember from last week, we're trying to work on chunks in FlowSpec V2, the basic. Then how can we add to the basic some more filters easily, and then add actions and non-IP filters. Next week, we'll be handling Team 3 and Team 4. Okay, and these are the dates for the meetings. Today is Team 1 and Team 2. Next week is Design 3 and Design Team 3 and 4. And then we'll take a break. On 5:30, we'll have on 5:20, we'll have another type of IDR interim. And then we'll start again in June. So let me review what we went through last week. I'm going to go very brief, but you can see this in the draft. There are rule groups. They have sets of rules. They have filters to match and actions. We're trying to put user order in there. The identifier is a debugging aid because many people group rules not only by the order, but perhaps by some customer identifier. So this identifier is debugging. You have rule match conditions and you have rule actions. And we believe there should be, that is the co-authors and I believe there should be action order. And the working group in adopting the original FlowSpec v2 thought so as well. We sometimes suggested there might be an action name, but that didn't really go forward, so I still put it in. Now, previously we had filter types, and the first time we talked about in Design Team 1, the IP filter rules, just for the basic. And the thought that people had from the original discussion I had with many implementers is they just wanted the IPv1 filters and the IPv1 actions to directly transfer to FlowSpec v2 with user ordering. So I tried to respect that by assigning an IP basic filter rules where the ordering is exactly the same as in FlowSpec v1. As I mentioned last week, the packet format looks like this for basic filters. You have the order, the identifier, the filter type of one, a length, and then the components where the TLVs, where you have the component type, the length, and the values. And again, you can read the original FlowSpec presentations for that. These are the original FlowSpecs. You may have seen the extended filters with TTL, SID, and NRP in the hop by hop where you can see SID in the IPv6 routing header and NRP in the hop by hop IPv6. There are some non-component matches, but we decided for the basic in discussions to leave those out and simply for the IP basic. Again, how do you match FlowSpec v1 and FlowSpec v2? They're two different LRIs, but if you're combining them in your router, you probably want to put them together. So we tried to give some ordering suggestions because you receive these filters and then you place them in your device's packet filtering engine. So we have a few basic rules because people ran into trouble with that with FlowSpec v1. Rule 0 is permit all. That is inherent in the FlowSpec v1. Rule 1 to rule n-1 would be FlowSpec v2 with user order 1, 2, 3. And at some point you configure the rest to put the FlowSpec v1 rules afterward. The basic rule is if you have the same user order, then order by component number. If you have the same user order and the same component, then order the multiple components using the rules defined in a component, which means every component must define an ordering. The actions we had in the basic were done in extended communities, and um, that will they were generic, V4 and transitive. If you look at the ordering here, I only have one suggested change. That's what happens if your action fails. And I call this the action chain ordering that says if it fails, what do you do? Do you just stop? Do you keep going? Maybe you do something else. Maybe you roll back. Maybe you do best effort. And that's something I'd like some feedback. There is generic transitive ones to try to do a action based on an interface set. We'll go through that today, or redirect. And these are redirects either mirroring or to an indirection ID. And again, V6 has some of those. Okay, I'm assuming this is basically what you've read about and remember from last week. So here's the first question we're trying to get some feedback on. Um, does the user ordering support the use cases for the current set of denial of service actions? And I sort of wonder if you have any background on this. Uh, any thoughts, folks? Any new thoughts? Maybe Nan or Nat, do you think we've got the user ordering working right?
Hi, Susan.
Yeah.
I am wondering that as we have the user ordering in FlowSpec v2 rules, do we still need for example, need to define to maintain the FSV1 ordering mechanism? Because in most cases, in FSV1 components, we have a reasonable ordering of those filters, at least right now. So we can have interpretation for those filters so that, for example, for the IP prefixes, it's trying to mimic the longest prefix matching behavior on the router. So basically, it's easy to understand and monitor or in operation consideration. And however, as we add more and more components in FlowSpec v2, especially upper layers FlowSpec components, it becomes harder and harder to memorize or decide how these filters are ordered. So yeah, maybe we can discuss whether we should keep that or not. And for the filters that with the same order, maybe we can only keep the FSV2 type and the order itself, and probably some rule grouping mechanisms like APN rules to in the key fields of that NOI, while keeping other components in the non-key field of that NOI. So if we receive the same key fields, the two FSV2 routes of the same key fields, maybe we can consider that a newer version of the FSV2 rule. Yeah, probably a little bit lack of consideration, maybe worth some discussions here.
This is the discussion I would like to have. Here's the first thing. If you do total user ordering, as I think you just mentioned, the user ordering can make everything specific. You can say user order 1 and then 2 and then 3 and then 5. But here's the problem. Many people have also said, well, I want to still have default ordering, which is ordering by component number, number 1, then number 2, and then number 3. So I've got requests for user ordering and then component numbering, and then because they want default, they say, okay, I want to say this is priority 1, and then this is priority 2, but I want to order within it. So much as I'd like to go with either just user ordering or just a new type of default ordering, I don't seem to have a consensus. Part of this, thank you, Nat, is why we're holding these meetings, because that's a question we've asked to everyone. Does user ordering mean we can give up on default? If you like default, how are we going to order it? So anyone who has thoughts on that? Jeff, I think you're next in the queue.
Yeah, I have a couple of things to respond to. So your original question is, does FlowSpec v1 rule ordering work? The answer to that, from my perspective and most of my customers, is mostly. Where it occasionally doesn't work out is that sometimes people's firewall implementations don't take certain patterns that are sort of encouraged by FlowSpec v1 ordering and build nice firewalls to it. The usual example I give for that is, let's say that we have, for destination 10.111/32, we're going to match on TCP port 25 for SMTP, and we're going to say rate limit, and then we have rule A, and then for the same destination we say match fragment, and then we say discard. And this may be a common pattern that people are trying to use to protect their mail servers, where these pairings of AB for an arbitrary destination will be deployed in a template fashion in the network. And in our implementation, as an example, these ABs do not optimize nicely together. And the consequences, instead of ending up with what can be observed for this case, all the A's and all the B's can be run separately because they don't share dependency fate, even though they have on the same destination, because there's not a more specific relationship. And if you were to group all the A's together and all the B's together, it optimized great. Basically match TCP port 25, here's a list of prefixes. Match fragment, here's a set of things that drop for these prefixes. But if they're ordered AB because of what FlowSpec v1 wants to give us to, it's going to end up with a longest run firewall rule, and this leads to performance issues. So that's one piece of your answer. Pause there to see if there's any questions.
Nan, anyone, G, since you're working on the NRP, any thoughts on this?
And while we're waiting for people to NQ, so the question Nat asked about, could we simply drop things? So even if we go with the version that you had displayed and say that we have the ability to suggest rules, you still have to have protocol behavior that's correct when everything or more than one thing shares the same ordering number. We like a deterministic tie breaking in BGP when we can get away with it. For firewall purposes, if we get things that are of equal user order preference, it still needs to fall through into a order. And the FlowSpec v1 thing for DDoS situations works out okay for that.
Any other thoughts?
So another point Nat raised that hasn't been a deep part of the discussion yet that ties in the user order. So would you mind displaying the packet format just to have a display point? We have Nat mentioned key and non-key fields, and certainly a lot of our newer NLRI formats are moving to the point where we do actually make those types of distinctions. where this is very important for FlowSpec in a couple of different aspects. FlowSpec v1 does its ordering effectively by canonicalized sort order of the component types. And then effectively, when things are equal to each other, the specification just says do a bitwise comparison, like the C memory compare function. Where this can matter is if we're going to say these sorts of things, non-key data inside of the packet becomes very important. So the thing you're not displaying right now is you have that identifier that you're wanting to use as an advisory thing. That's an item that we probably, there's some encouragement to have it in the NLRI because it allows per NLRI decoration. We have a lot of examples of things that we're liking to do with that these days, but that needs to be a non-key field. That one is probably immutable. You set it, and it's probably going to stay exactly the same value across deployments. I think that will be an interesting design discussion as we work through things, especially with the second half of the presentation today about interfaces, because when the authors for the interface set draft that we currently have out and has some deployment, we're talking about, well, does this belong in the NLRI? Does this belong into something in the path attributes? In this case is encoded as a extended community. The choice we made was realizing that if you pass this across provider domains, there's a very good chance that some provider A's interface set mapping may not be the same as provider B's, even within the same operational domain. And you need the ability to remap that. And you can't do that if it lives in the NLRI. So the same question is going to apply as well, I think, for the identifier that you have in the FlowSpec v1 packet, FlowSpec v2 sample packet.
Yep, and that's part of the question. Some people have mentioned that if your identifier is there and it's constant, but it's something that might identify a set of identifiers. Let's say these are all for customer A. That order plus customer A might be a filter match. Okay, so, or color A if you had a type of customer order and then gold service. Okay. Anyone else want to comment on that first question? Jeff and I really would love any type of feedback on this. We'd like to take it in the design team. Just a minute, I'm having trouble getting to question 2. Okay. Nat, did I answer your questions?
Yeah, probably. If we only take the FSV2 type and the order of the as key fields, are we still encountering the problems that Jeffrey has mentioned? Because we can use the BGP best path selection algorithm to select a single best one filter that. Maybe I have misconsidered something, but yeah.
So let's
Go
go
ahead,
ahead and talk
Jeff.
through that. So BGP route selection isn't quite helpful here because most of that is basically finding the best exit for a network. And that's not what we're doing here. We're setting in firewall state. So things like, is this next hop closer? For a lot of the applications, probably doesn't make sense. Like the redirect functionality, redirect IP, that was actually something we talked about in terms of if you have multiple tunnel exits, which tunnel do you select for that? And that's very similar to other traffic engineering. But for picking the actual route, there's not a lot that route selection is going to help you with outside of some of the normal big things. If you have local pref set higher, you probably want to use that. But Just like anything else where you're using local pref, you have to be very careful when you do it to make sure that you really mean this to override everything. And local pref is typically used in cases where you're trying to take a lot of candidate paths from more than one provider and force one to be consistently picked. Hopefully with flow spec, even though it should respect that piece of BGP, the hope is that there's few enough parties injecting rules that you would want to decide based on local pref. And where this runs into the second piece of why is some of the flow spec ordering rules the way they are. As an example, couldn't you just simply number them sequentially and that should be good enough? Part of what FlowSpec v1 was dealing with, and FlowSpec v2 will have to address, is that potentially more than one device is injecting a set of rules. Maybe controller A and controller B. And this means that a receiving BGP router needs to decide how these things compare to each other. And if you have a single numbering space, which is what the user order stuff is intended to be, what does that mean in terms of firewall orders if, say, both of them send rule order 10? And this is probably a reason why we will still need to keep some form of the default sort order.
Nat, the default sort order I call also on this slide the component order, which is ordering by component types. And some of the proposal then is that component types 4 and 6 are the same, being because that helps have some parallelism, but that's our best guess as at what might be working for the component types. Component types we might be able to change, and I'll show you in a few minutes how we might be able to change component types between different IP filter types, but the basic mechanisms of ordering followed by component types followed by ordering within component types is a fundamental idea that we're trying to suggest. And if I can get all my slides, that was the slide back at, let me see if I can get it. Again, this is the ordering types that, this ordering is what's fixed. It is possible, and I guess that's something I might want to launch into, how we might change component ordering types between basic filters. So let me go through the other questions and then I'll dash off to that. The other question, Nat and Nan and Spring, is what happened, and Young and Yusha, what happens if you want to have one controller and suddenly you get a denial of service or something, and you want to add a new type of filter? Well, you might want to add a new packet filter or a new routing filter, but you might want to also add non-IP filters. And so we're trying to make sure that ordering works. We believe ordering works based on user order followed by type of user order, type of filter, IP or L2 or something. And we're looking today more at groups and interfaces. Can we handle those? Any questions of thoughts about this? Okay, I'll raise this on the list as well. Maybe we can get some feedback from people. If you, Nat or Nan or Ji or Shuping, any thoughts on the errors? What happens if you have an error? That's one place where people really had a problem. When the errors happen, the user order had problems. Go ahead, Jeff.
So dealing with errors in a sensible fashion is a thing that we definitely need to do. One of the less happy pieces of FlowSpec is that we've had network outages because BGP sessions flap due to errors in here. Thankfully, these days people run it more as it was intended to be, and not trying to run their v4 and their FlowSpec over the same sessions. They tend to run parallel sessions now, so operationally this is less severe. But when you have an error that's detectable and can be corrected through treatise withdraw, that's definitely what we should do. However, there's a consequence here. If you have a rule that's failing to get deployed in your network for some reason, let's say that some subset of your devices accept the route and some decide that it's malformed, well, the ones that are malforming it, at the very least, if they treatise withdraw, aren't deploying it, but it means that a portion of your network is not covered by the rule that you thought it was. So when we do these types of treatise withdrawals for FlowSpec, the user needs some level of notification about it. And certainly could put text in there about that logging should happen, but given the security nature of these things, we're probably also looking at some form of telemetry as a feature that we want long term.
Okay. Last call for any questions. I've given in there an idea of what happens if the error occurs in the actions. I think, and I believe the validity checks from FlowSpec v1 are sufficient. I'll raise each of these questions on the list and we'll go from onto the V2 slides. Just a minute. Okay. So let's talk about the filters that we're working on. And we're going to start today's filters with my overview of what I've got in draft IDR FlowSpec VT More IP filters. That's an extension of the original FlowSpec V2 spec that Donald and I worked on. These are how we might put more IP filters. Then I'm going to quickly review one use case for it for of mobility for the 5G, and then Professor Ku and Husha are going to go ahead and give us an example of deep packet inspection in the payload. And then Jeffrey and I are going to talk about extended community and why that was used. From there, we will go on to look at emerging filters. And I will give the CATS review, and Nan will talk to us about the SAFE network. And then I will, with Shuping's help, go through APN. Then I have 6 questions for you to think about. And again, I'll start a list discussion on that. Okay. So again, we're back at our packet format. We have our order, we have our identifier with the caveats we've had. We have the FlowSpec filter type. Now, what I propose for more filters is to be able to break the rules of that we agreed on with the V1 people by going to an extended filter rule set. In that set, we would put a version number. Why? Because perhaps we need to go through filters when we add them and say, today I'm supporting the V1, but I'm going to add these filters. And so when I put a filters version, you know which filters might come to you in that. Now, otherwise we have no versioning on the FlowSpec V2. That this interior version within the component is a concept. The cost is that once you put the component type, the actual extended IP filter types, you have 4 bytes for a version, or we may decide 1 byte. But there's a version number so you know what components might be coming afterward. And it's one way to allow revisions of more IP filters without freezing the spec at one particular time. The people receiving that, the implementations receiving it, excuse me, would look at the version and say, yep, I have this version. I know I can support the components for that. Go, Jeff, do you want to pick this up now or later?
Do you want to talk about this in context of versioning and maintenance, or do you want to move this a little bit further later?
Let's look at the component types and then talk about it there. I'm going to go one slide further and then we're going to come back. So here's our current components that we've approved. On the left-hand side here, 1 through 13 is our current approved. The ones that are in IDR drafts, which are approved, are some sort of TTL, either as the first thing or maybe as number 14 in components, SID filters in the routing header, and NRP. The proposed new ones are payload match, group ID. I put group ID to sort of take us into the discussion. There's been a proposed to filter on APN ID, Savi interface group, and a CATS ID. My proposal in the draft tears actually tries to look at group ID in a different way. But what's important about all of this is that we will have new component types, and we want to be able to add more, because what I'm seeing in the proposals is people want to add components for other filters, and we could make this an IANA thing where we have a proposed spec, they ask for a new component type, and we approve it. Because what we found in FlowSpec V1 is people wanted to add new filters. If we add in the extended filter type, perhaps we can go through there. Now, Jeff, I'll go back to the picture and you can make comments.
Yeah, sure thing. So you're hitting the key piece, which is people want to add stuff, and what do you do about that, both in the protocol and far more importantly in deployment. So protocol-wise, the thing that hurt us most in FlowSpec v1 is that the protocol was not a TLV format. It was often a type value format with implied lengths, and this means that you can't safely add new features into the NLRI string. And we're addressing that by making sure that the filters that we're doing are strict TLVs, and that's going to include all the old ones. So with respect to that piece of adding new components, that's not a big deal anymore. It's now a type length value. Theoretically, if you don't understand the thing, you could at least do syntactic validation for the thing. But that doesn't help us with the second piece, which is deploying the stuff, which is let's just pick an easy example. We add the deep packet inspection type as a new entry. If it's basically a standalone filter, or maybe paired up with a destination address, now, what do you do on the portions of your network that do not support that component filter? You have a couple of options that may make sense, and you've got some of this discussion in the context of actions, but it's also appropriate for match conditions too. One option is you ignore it. You don't support the thing. But you can tell that you don't, and maybe you are capable of passing it on. Although one of the questions you may have is, should a router that doesn't understand a thing propagate it? Route reflectors are an easy example of yes, you want that to happen. Maybe in some of your cases, if you can't implement a filter, you don't want to pass it further in your network because maybe you have dependent actions that care about this. That's where we run into the second problem. When you're building your filters and your controllers to deploy, if you have dependencies in the system and you're not sure what portions of your network can implement it, it becomes very tricky to actually deploy complicated flow spec. And some people's answer to that may be, don't do that. If you don't know that it can work universally, maybe you simply don't do it. But that means that incrementally deploying new features can be challenging. And in some cases, deploying the features will happen in an intentionally layered fashion. Some devices like your edge, AS border routers, as an example, if your internet service provider may be able to do the very high level flow spec v1 stuff fairly efficiently in its firewall, but can't do something like deep packet inspection. And maybe you want to just say it's okay for you to not install these things. But maybe the devices that traffic is redirected to, those can do it. So try to tie the statements together. I think that the TLV format means that it's safe for us to add new things once we answer the user ordering questions. I think that there is a strong need for controllers, at least, to have a sense of what can actually be deployed within a network. I think that there's probably some need for flow control about what do you do with rules that you don't understand.
And I think I think the current set of specifications, the draft Hare's IP filter, has the first two, the general format and the expansion. And I hope it has the last one, which is ordering. But the question has been, did we cover what happens if you don't know about a filter? So that may be helpful. Okay, maybe I'm going to go to the questions, which you saw on the list. Does the extended version help with deployments? We think it will, but please let us know. Do we have the right things for IPv6? Notice we've put a port range in there. Maybe we should have a better port range, but I think that wasn't needed, that it was covered by fee 1. What filters should we add? We're going to talk about some of that. And we're back to user ordering. Questions that Jeff's met. Again, what happens if errors are detected? So the questions are going through the very thing that Jeff had. I'm going to ask if anyone had any questions that they'd like to raise or comments on that. Otherwise, I'll do a list. Okay. Please don't, this is a really, we want to talk about things, but let's go start to the upper layer. And I'm just going to go a few minutes on the draft DMC IDR flow spec TN aware mobility by Dunbar, Mahajan, and Chandrai. And then Professor Chu and Khuja are going to go through the deep packet. So most of these you're going to find a 2 slide format. The purpose behind the TN-Aware is to handle the mobile network to IP network transition. They're using FlowSpec v1 UDP range as their check. They're wanting to do that first, followed by source and destination filters. Notice where user filtering is important. They're querying for a certain set of UDP ports that they're going to look at. They're looking at the source and destination afterwards to decide where to send something. And then they're using a generalized indirection ID action. Once they've matched, that's that basically says, okay, we've matched. Now we're going to look within the action in the extended community and decide what action to take further. And I will go through that, but essentially the bottom line after that is they're indirecting via a particular ID. The user ordering I've got here where you've in more detail, where you have a user ordering with a port range and then source and destination. I think that's pretty normal. Any questions on that use case? Has anyone seen the 5G use case? Okay, I'm going to let Professor Zhu, Young, and Yuzha go through the next section. You can just, I'll run the slides since there's two if you just go through this discussion.
So Yuja will present, right?
Wonderful. Yuzha, go ahead.
Okay, I will start the presentation. And hello everyone, I'm Yujia from Beijing Zhongguancun Laboratory. I will introduce the packet content filter for BGP FlowSpec. This filter is proposed because we find that large-scale DDoS attacks occur frequently, and some of the traffic has specific packet characteristics. When when the defending against DDoS attacks, we face the problems of insufficient network cleaning resources and high defense costs. Some vendors such as Juniper, Cisco, and Huawei have already have ACL-based payload filtering capability in their routers. However, ACL have to be configured manually and the response time is slow. At the same time, BGP FlowSpec can implement flexible traffic matching rules and fast rules delivery. If we add the packet content filtering, we can achieve flexible traffic filtering at the router, which can reduce the cost of the cleaning and improve the overall network defense capability. So the following is the definition of the packet content filtering, which includes component type, component length, and value. Each value represents a filter rule, and a FlowSpec message can contain multiple values. Here is an open question. Is the length field to be defined as one octet because compared to other filters, the length of the packet content is variable. Maybe we can discuss about this question later. And next slide, please.
You should see the slide at this point, so why don't you go to the second slide description?
Okay, I can see the slides now. And here is the definition of the filter after expanding the values. The first is p-type. This is a new field compared to our last version. It defines the type of the packets, which are IPv4 or IPv6. because some filters are added to hardware that are IPv4 or IPv6 specific. And the second are O-type and offset fields. They define the starting position of the packet content used for matching to avoid the effect of variable header lengths of different packets. We define the O-type in a hierarchical way. People can choose where is the start of the offsets, which as IP header, IP payload, and TCP or UDP payload, and use offsets to determine specific matching field. In this way, we can definition.
We lost your voice. We actually lost. We're not hearing you, Yuzha. She will drop and come back. There she comes. Go ahead, Yuzha.
Okay, I will start again. So the third is the content length field. It contains the length of the content and the mask in context. Based on the information provided by equipment vendor and operators, 8 octet is usually sufficient for the identification of DDoS attacks, and the router has the corresponding computing power. And finally is the content and mask field. The content provides a string to be matched. Mask is a string contain 0 and 1, where 1 represents what will be matched and 0 represents characters that can be ignored. The content and mask operated end by bit to get the final content of the packets that need to be.
We've lost Yuzha's voice again. The key point is also a secondary point that I hope is there in Rule N is this one, according to the original definition, might have multiple
Sorry,
content filters.
sorry, my network is now not good. And there are the full definition of our filter. And I hope they can get feedback about the field settings.
Thank you. So I'm going to go on with that, but that's one type of filters that we're considering. I'm going to pick up, please, the interface filters, and we'll see if we can talk about that. But content filters falls within our original DDoS sequence. So, um, Jeff, do you want me to go with the start, or do you want to go through it with the slides? It's up to you because it's one of your drafts.
So I'll start with what the intent of our draft was. Some of the stuff you have in here is not quite our original use cases, but it's overlapping. Actually, could you flip to the packet format real quick? I'll maybe make this a little bit easier.
It might be make it easier.
There we go. So the original motivation we had for the interface set feature is that sometimes you want to apply flow spec rules selectively, to some sets of interfaces in your network. So we talked about when I was discussing what happens if you want to deploy your filters across your network and maybe a brand new component's not understood. We also have cases where you intentionally want to say some of these filters are only applied in specific circumstances. So using the example I gave a few minutes ago, maybe you're protecting a SMTP mail server in your network, and you want to apply only towards your internal infrastructure, and you don't want to do anything necessarily bad to somebody else's stuff. Certainly you could do that by restricting the destination addresses that you're protecting, but maybe you have like a wildcard TCP rule that maybe you only want to apply towards internal resource interfaces rather than customer interfaces. So that's one very specific example, but the sort of general case is you want to apply your FlowSpec rules selectively, and interface scoping is a common thing for firewall deployments. So the purpose of this feature is to allow you to identify what set of things you're wanting to apply this to by a group. And part of the reason we chose a group is because we didn't want to solve a very nasty problem, which I think we'll actually have to look at, especially when we get to the source address validation use cases, where how do you talk about interfaces on individual devices in a consistent way? We don't have that in IETF as a general thing. One of the places we have something that resembles is the SNMP IF index, but that's not terribly stable, across long histories. So it's been problematic for use in a lot of applications. What we're looking at is a little bit closer towards an equivalence class. This is the class of things or the group of things that is maybe your internal resources, your customers, your transit peers. You're actually constructing equivalence classes that make sense for you. And while there's probably some common use cases that will broadly apply, there's not a sort of universal agreement on these things. So right now it's just a generic number. So what went into the original spec that we did was we pulled out a certain number of bits for a group identifier. And we didn't actually do the full 16. We did 14 because we wanted to leave 2 bits for directionality. And this will also hit one of the what do you do about incomplete support features. So the original intent was we want to be able to choose on an outbound or an inbound basis, whether things are applied for your firewall. Maybe you're only filtering on the outbound direction of your firewall. Maybe you're filtering on the inbound direction, for a given set of interfaces identified by a group ID. What we've found over the lifetime that this has been done, this is absolutely implemented by Nokia. The other implementation, I don't know I'm allowed to talk about at the moment. Juniper does not have this at the moment, but we spec'd it out. Is that inbound filtering is what the firewall infrastructure really wants to do sort of universally. So the O bit is effectively not really deployed. One answer is we simply remove it. We occasionally get discussions about maybe it's a necessary thing, and since we have people that have different use cases, directionality should be something that we should generally talk about. Past that point, it has a AS number for basically diagnostic purposes. If you flip back to the prior slide, we can talk about some of the equivalence classes. So you hit the points quite nicely here. It's like using the groups to identify like internet service providers, VPNs, customers, peers, etc., or even wildcards. These are examples of how a provider might want to leverage this feature. Where we run into interesting headaches is when we want to maybe do an exact interface on a very specific device. There's not really enough bits to do networks past a certain size. 2 to the 14th is a very large number, and certainly you could carve off a portion of the spaces for equivalence classes, maybe 1 byte's worth of data, and then you reserve the rest for explicit numbering. But then you have a very interesting provisioning problem, and as I mentioned, we'll be discussing that later in the context of other people's proposals. Questions? Nat, you have the cue.
Okay, so I believe the outbound direction is useful in some very specific use cases which we are currently using but it's for very special customers. So I believe the outbound use case is useful in this case. And for the grouping consideration, maybe we can consider to introduce some kind of grouping mechanisms from Y committee draft, that we have some unassigned neighbor class values, something like that. Maybe we can do something about that. Yeah.
Yeah, I agree with you. So fundamentally, and I've mentioned this too before, the use case for equivalence classes, I think, is pretty well understood. There could be use cases for explicit interface identification. White communities for routing policy does try to talk about some of these things, and white communities does give us the set of ideas that we can apply these things on a more policy-driven basis. What I'd like to encourage the group as we work through each of these different things, let's spend a huge amount of time focusing on the explicit encoding up front. If we get the use cases defined well, we'll probably find some natural structures. Maybe white communities is it, maybe it's an extended community, or maybe it's something brand new. None.
Hello. I will give a presentation on BP flow spec for source request validation. So we and co-authors are also considering how to use flow spec to disseminate subrules. And to achieve that, we need to some information like interface set. And we also talked about that before. Can you share more considerations on why you put interface set in the action community instead of the NLRA?
So the reason why we made the choice to put it inside of the extended communities rather than NLRI was because we had use cases that the authors were working through at the time where two sets of providers may actually want to coordinate with things, and they would need the ability, as things crossed AS boundaries, to be able to change things. And sort of one of our fundamental rules that we have to respect, even as we look at some of the things as key or non-key fields inside the NLRI need to not change. They're immutable. So if you put it into the NLRI, the group ID has to universally mean the same thing for every single cooperating provider. Whereas if we put it into a path attribute, we chose extended community, but it could go into something else. Path attributes are allowed to change on a provider by provider basis. And I think this is going to be a general thing that we're going to have to decide as we work through the proposal here. There's going to be some flow spec things that need to be match criteria, which need to be mutable for the use cases, and therefore they can't live in the NLRI.
But I also think some may be more global. So Xuping, when I reread Xuping's APN, I found both. So it's the mutable. It's not clear that they're always going to be in action. It's not clear that they're not both an action and a filter, which probably leads us right in naturally into the next set of slides, which are giving those use cases. Let me go ahead and project those. The first one is cats, which I'll present, but is the work from Lynn, IDR cats flow spec TS. The cat ID is set in the IP packet by filter process. I haven't quite figured out how that works. I don't know if an action would set it in the filter process. That became, or if something would identify where the cat's ID is. That's a question, but so the cat's ID is still a little vague on, are they going to define this is what we're using for cat's ID, the SRv6 SID, are we using something else? So uh, once they do that, then they're going to need to filter based on it. So I couldn't really figure out how that was working for cats because I don't know if they're just going to reuse. They hint at reusing the SAID. They could use a hop by hop in the V6. Is it really working for V4? I think I need more input from the authors. If we did do it, they would, and they don't specify it, they might specify a packet location, a fixed location, or they could use the hierarchy that Yusha was using, where you tell it's this type of packet and it's this offset for this length. I don't, so I need to find more. And I'll turn this over to Nan, who will go through his slides or through this set of slides.
Okay. Thanks, Sue. In this draft, we propose to define a new kind of filter that is another kind of interface set. And this set can be configured locally, and it has the similar meanings, just like the draft presented by Jeff just a few minutes now. For example, the interface set can represent all the interfaces connected to a customer network. With this interface set filters, we can disseminate sub-rules to routers. When a packet arrives at the router, we can match the packet by using the incoming interface of this packet and the packet's source address. If the packet passes the validation, the packet will be considered valid. Otherwise, the packet will be invalid. For invalid packets, we can discard the packet directly, or we can do some other actions like sampling. Next, please. Here is the encoding design of the new filtering component. We plan to use one or more pairs of operator and value with a combination of operator and value. We can represent a set of interface groups. The design of operator is the same as the current one. For the value part, we have a variable length. The group identifier can be 6, 14, 30, or 62 bits. And we have two flags. The first flag is V. It means if the flag is set, the interface set is valid for the source prefix. If the flag is clear, that is unset, the interface set is invalid for the source prefix. And the second bit is R. R is a reserved flag. An example of the sub-rule dissemination is we can carry to NLI can carry a source prefix component together with a interface set component. and the sub rules can be used as an additional method to improve the maybe accuracy of existing sub mechanisms. Okay.
Thank you, Nan. Jeff, would you like to bring up the discussion of hierarchy?
I do. I had originally raised my hand about the cats item, so I'll hit that briefly. Then I have also comments about especially this slide. So for the cats item, one of the things that is being done with firewall filters and different vendors at the moment is using the firewall as a classifier to do various things to the packet in terms of its forwarding behaviors. Now, we obviously have redirect as a standardized thing, but to give it another example, you can set the DSCP bits. And this is useful for doing class-based filtering, and that's how people can do topology splits in some cases. The CATS type use case overlaps the ability to do some sort of other packet metadata markup that allows some other part of the infrastructure to do something more clever. DSCP is obviously an IP supported one. Some of the use cases overlap things like service function chaining. So maybe that answers your question about how CATS might do such things. This is already being done by some vendors. It's just a matter of standardizing it. Pause there for questions before I hit this point on this slide here.
I agree that service forwarded chaining is already doing something like that. There's a action that does this to set up service ID, but yes, this is existing technology that seems to be moving towards standardization.
Okay. So hitting a couple of comments about the format here for matching large sets of interfaces, where SAV is the use case. So the variable length for the groups, I think is a nice touch. It leverages stuff that we already do for doing different group links out of FlowSpec. So that's a good reuse of the technology. I have concerns, as I mentioned from when I was giving my end of the proposal about putting these things into the NLRI because these things become immutable. I think my secondary concern is that large lists of these things is going to be potentially one of the use cases that need to be dealt with. So choosing the source address validation use case, you may be applying stuff to a group of interfaces identified by a specific number, maybe to the all customers interface set as an example. But there will also probably be use cases where you're trying to identify individual interfaces by an interface ID of some sort. And this means two things. Thing number one, there's a need to identify the class of these things. Is this a class, a generic user level defined class, or is this a well-known numbering space? Exactly how we identify that, as you have in your example here, you have two bits that you've chosen to say it means very specific things. Maybe we have a bit that ends up getting used for saying that this is a well-known interface ID, like the IF index or a user group ID. I think my second comment, and this is a repeat from the IDR presentation at 119, I think FlowSpec is probably not the best format for doing source address validation since it's primarily just matching on sources. And certainly while the format can support source-only filters with group lists, it might be one step too generic for source address validation. But this work is early, so it's a good discussion to have. Thank you.
I think the pros and cons. Go ahead, Nan. I'll let you go first.
Oh yeah. In our use case, we can use FlowSpec for source address validation within AS. So as you mentioned, the interface set may have local meaning, so there will be not a problem when we cross ASs because one of the main use case is disseminating the rules within an AS. For if we want to use the technique of crossing different ASs, I would also think about this problem. One of the idea
We lost the last sentence due to problems with the sound. Do you want to type it in the chat window? Or just try to say it again. Okay, I'm gonna let Nat interrupt me at any time. This one makes me shy because Shuping's here, but I will try to do my best at my reading of this. The group ID could be an option in the IPv6 hop by hop header, or an option in the destination, or a TLV in the SRP header. The APN ID match, in my reading, I think it's a list, a single match, but it might be a list. That might be my failure of reading the draft. Shiping, was the APID match a single or a list match, a list of IDs?
It's a single match. Yeah.
Okay, so it's a single match in the filter, and then the group ID is also set like Jeff did, with a group ID and a subgroup ID in a slightly different format. So you see actions occurring in both ways. I like the subgroup ID because the subgroup ID might be able to handle the flags that Jeff and the SAV network is doing. Here's the format in the extended community. So I like that. And then it uses the action of packet traffic action of the 0, if not matched. This test stops. If it's set, then occurs. It was a nice addition to the things I saw from Jeff and from Nan. Thank you, Nan. I'll read that. So I see 3 or 4 various things about the grouping. I think it's an important concept, but I think we're early. Jeff's got one particular case. Safnet's got another. APN's got a nice mechanism. I think it's worthy of a lot of talk and consideration, because it seems to be the action is important, and then perhaps filtering the result of the action. Let me read Nan's comments while some of you think if there's some other. Nat, do you want to, since your conversation as well, would you like to make your comment on verbally about what you've made in the chat window?
Okay, sure. Because to carry, as far as I know, for SAP rules, they might contain multiple source prefix as a list, multiple source prefixes in the same rule, and maybe they are they are valid for the same interface set. So maybe allowing multiple appearance of the same of the source prefix component would made the encoding more efficient in this way. Just my thought.
And that's an interesting thing of appearing. If it has user order, it should be able to appear multiple times because the source component can appear as many times as it's a rule. You have rule number 1, source validation 1, rule number 2, source validation 2, or sequence of source validations. The Nan said FlowSpec can be used to disseminate part of the FlowSpec frequencies, but not all. Rules can also be generated by SAV mechanisms. That gets to the case of IDR distributing everything and something else providing an exception. That may be very efficient. As I mentioned last time, BGP is a great multicast distribution of filters, but you might have other sequences, PCE or netcomp, RESTComp is something. We've come to the last set of our work. The thing I'd appreciate for folks is if when I send out comments on the list, if you'd try to send feedback. We need to try to close off on the basic IP draft so that people can actually implement and look at what filters. I think group discussion is going to go on, and it's a very important one because we see new discussions. Any comments, Jeff, before we close the meeting?
No comments.
Okay. Well, I will send out the comments on the list, and next week is the action. So today you should see your action draft proposal and a list of reading and questions. If you're joining next week, please go ahead and read up on the draft. Next week, Donald, the first hour, we will look at the actions. And for the last half an hour, Donald is going to give us a presentation on L2VPN and NVO3, which is the non-IP stuff. Excuse me, I should probably also say I'll grab 5 minutes to do the MPLS filters as well. Well, have a great week. Thank you again for all your presentation, and for all those in China, thank you for staying up late on the Monday after a long holiday. Have a great day.
Thank you.
Thank
Bye-bye.
you. Bye-bye.
Thank you.
Thank you.
Goodbye.
Thank you. Bye bye.